This video is going to introduce a problem about two brothers who are in a race. And this first part of the worksheet just kind of goes over like some reminders of what we've done so far in terms of writing equations. We had distance equals the rate times time. We had another one where the amount of money equals the upfront fee or upfront donation plus the amount of the donation per kilometer times the kilometers. And we had some other equations too. So that's what that is, just as a way to kind of remember what we've done so far. But let's get into the problem we're working with today. So there's two brothers. Emil is the older brother, and has found his walking rate to be 2.5 meters per second, just like Leanne had a walking rate of 2.5 meters per second. And so he goes home and he has a little brother, Henry, and he's like, well, let's see how fast you are. So he times him and figures out that he actually walks 1 meter per second. So that's his walking rate, just like Alana. So that being said, I'm going to come down here and we're going to examine what happens over time if they did a walking race, then Emil would clearly win because he walks faster, right? But he wants to give his brother a chance because he has a little brother and he wants to make it fun for him. So he decides to give his brother a head start. So this is a little different because we haven't done one like this before where he actually starts at a different spot. So if you can imagine, like if this was the starting line, and we're going to go this way. So if this is the older brother, he's back here at the starting line and he gives his brother like a 45-meter head start. And then what's going to happen is as they walk, well, the one brother's faster than the other. So as they walk, eventually, the faster brother would catch up to the young brother, even though he has a head start. And that makes sense. So what we want to figure out is where at what point would they tie? Would they be at the same spot? Okay. So you have some questions here, like what are the variables in this situation? Why don't you answer those questions and pause and come right back? So our two variables here are time and distance. And I want you to notice the way that I wrote that. I wrote it in parentheses and I wrote time first and distance second. And what that's communicating to somebody is that time will go on the x-axis. I wrote it first in the coordinate pair. And distance would go in the y-axis. I wrote it second. So that is a way to tell somebody that time is the independent variable and distance is a dependent variable. And then I recalled the two walking rates that we were already given in this problem. The 2.5 meters per second and the 1 meter per second. So get caught up there. So what we're going to do is we're going to find the distances over time. We're going to start just going up by 1. But after we get to 5, we can jump around as high as we want, okay? So keeping track of data in a table is a very useful way of being able to analyze a situation and help to make predictions and solve problems. So we're going to start by going up by 1. Let me start with Henry. I'm going to start with Emil. Emil's blue. So Emil's the older brother, and he's starting at the starting line, which is 0, and he's going 2.5 meters every second. So I'm going to add 2.5 meters. As the seconds increase by 1, he's going 2.5 more meters. So that would be behind my face, would be 12.5. That's 12.5, not 1.25. Oh, sorry. Okay, good enough. We can go from there. Now, Henry does not start at 0. See, Emil's at 0, but Henry has a head start. So Henry actually starts at 45 meters. And then he continues at 1 meter per second. So now he's at 46 meters, 47, 48, 49, and 50. Okay. Now, at this point, you can see how far apart these numbers are. They're getting close together, but they're still pretty far apart. So going up by 1 second is not a good strategy. So what you're going to do to finish this problem, because remember, you're looking for where they're going to be the same distance. You're going to choose a different way of going up and try some other numbers in the table. Choose different times and find the correct distance.